So, for Chapter 9, I'm going to talk about an article about ion thrusters and their use in low Earth orbit for satellites. So, the first thing this article talks about is why you want satellites in low Earth orbit. We want them because they come with a few advantages. They have better vantage points for new commercial operations and Earth observation and telecommunication connections. So, why do we want ion thrusters in our satellites orbiting at low Earth orbit? Well, there's not really a need for fuel, and I'll come back to this later. Less missions for refueling these satellites because these satellites are running on would be running on chemical thrusters. There's less waste because instead of just waiting for the satellites to come and crash down because of them running out of fuel or the waste of sending a refueling mission to these satellites like we do with the ISS. It's also much cheaper because we're not spending any of that money with these missions. So, what are some of the challenges that the ion thrusters are going to face? Main one is staying in low Earth orbit and not crashing to the ground. And also keeping fuel lower than 450 kilometers. And the drag of being in an atmosphere that low. Normal satellites will have to constantly be using fuel to resist the drag. And no ion thruster satellite at this orbit has succeeded so far. So a new paper comes out about an atmospheric breathing electric propulsion system. And what this does is it's basically it uses its atmosphere around it as a fuel source. It uses the atmospheric particles that are still abundant at 450 kilometers. And it uses those particles as fuel instead of preloading with a bunch of fuel and just waiting for it to peter out. And it possibly could refuel other crafts too. And right now, it's being researched by the U.S., EU, and Japan, though the ESA has the most research into this so far. So, what are the challenges for ABEP? The first one is maintaining its orbit at less than 450 kilometers. Right now, the sweet spot is 180 to 250 kilometers. That's because when it's higher, there's not enough fuel around it, and if it's lower, there's too much drag, so it won't be able to keep up. Also, there's elemental oxygen that corrodes parts of the crafts. So what really becomes the problem is its oxidization resistance, and not how much fuel it has. So, one of the things that they are proposing is its use in Mars. Because Mars has less atmosphere, this satellite can orbit at 130 and 160 kilometers, and it is more feasible to refuel other crafts in this system.